Okay, so 14 reads, if your suitcase weighs over 70 pounds, you have to pay an extra baggage fee. So remember I told you guys the variable and then the number in question. In this case, it's 70. Okay, so again, I'm going to have to choose from less than, greater than, less than or equal to, or greater than or equal to. So this is clear in the sense of, it says if your baggage weighs over 70 pounds, you're going to have to pay that baggage fee. It doesn't say 70 pounds. It doesn't say including. So these are not in question. The or equal to's, no. Your bag can be 70 pounds and you don't have to pay that extra baggage fee. So I have to figure out if it's less than or greater than. So if your suitcase weighs over, I don't know what my suitcase weighs. So if it weighs over, meaning if it's greater than this much, I have to pay the fee. So that means the sign I would use is the greater than sign. Okay? So if your baggage is 71 pounds, you're going to have to pay a fee. Okay? So that would make that statement true. Now let's go to number 15. It says, if you have 3 or less sheets of paper, you may want to go to Target and buy more. Again, X, I don't know how many sheets of paper I have, and 3 is the number in question. We're going to pick from these symbols to see which one works out. It says if you have 3 or less. So it is including 3. So these are not possible inequality symbols I can use for this inequality. So because it's including 3, meaning it could be equal to 3. If you have 3 sheets, you may need to go to Target. So it says it may be 3, and it says if you have less than 3 sheets. So the only symbol that would work would be the less than. If I have less than or equal to 3 sheets, I may need to go to Target to buy more. Okay? Okay, so let's go to number 16. Number 16 is writing equations. It says the 1,840 rock concert tickets sold were twice the amount of jazz concert tickets sold. Write and solve the equation to determine how many jazz tickets were sold. Be sure to identify the variable. So equations always have an equal sign. Okay, this tells me that there was a 1,840 rock concert tickets sold. That is a total. I can't change that. So that I'm going to put my total on the right side. Okay. Now it says the 1,840 rock concert tickets sold. This amount was twice the amount of the jazz concert tickets sold. If it works for you guys to work backward and do divided by 2 in order to find this side, sure, that's okay. You can do that. So I told you that the variable will tend to be on the left side. So if I divided by 2 here, I had to have done the opposite, right? So that means that this must have been a multiplication problem. Do you guys see how I did that? So this would have been divided by 2 on both sides in order to find x. But if you didn't know that, we can represent twice as many. Don't know how many, so that's my variable. And I can represent twice as many with the 2. So 2 times whatever that many tickets were. Okay, so my equation would be 2x is equal to 1,840. So let's move on to number 17. It says, at a restaurant, Mike and his 3 friends decided to divide the bill evenly. If each person paid $13, what was the total bill? Write and solve an equation to see how much the bill totaled. Be sure to define your variable. So my total bill, I'm going to say, is B. So what I need to do is everybody's total bill was 13. So that's my total. I know that they will pay $13. It's going to be each. So that means that if I multiplied that by 4, I would know what the total bill is. So if I multiplied by 4, that means I would divide on this side. So whatever that bill is, divided by Mike and his 3 friends, that means that there are 4 total, 4 of them total. Mike, including Mike and his 3 friends, that's 4. my equation would actually look like this. So whatever the total bill is, divided evenly among their 4 friends, would be $13 per person. Okay, again, if you guys need to work backward to kind of write these equations, that's okay. I'm not against that. I'm totally for that, okay? So that would be 17. So if you wanted to solve this, you would actually multiply by 4 on each side. And you would get B is equal to $52. So their total bill would have been $52. 52 divided by 4 is 13. Okay, so I'm going to go ahead and flip that over. Alright, so it says last Friday, Trey had $29. Over the weekend, he received some money for cleaning the garage. He now has $41. Write and solve an equation to see how much money Trey made cleaning the garage. So he now has $41 is actually a new total. So I'm going to place that on the right hand side. So I know that he had $29. So that is actually going to go on the next side because I want to try to get to 41. Okay. Now, he earned some amount. I don't know what that amount is. Doing yard work. Now, I want you guys to tell me, how could I do 29, whatever symbol's in the middle, X, to get to 41? So since this is smaller, I would need to add to X. Whatever X is, that would make me get to 41. Now, again, I'm not a fan of this order, so I'm going to switch these real quick, because I like to have the variable first. So whatever he made over the weekend plus that $29 he already had would be 41. So if you guys wanted to solve this, I would subtract 29 on each side, and I would get X is equal to, that's 30, I believe. He made $12. Okay, so that was the unknown amount he made cleaning. All right, and you can confirm that by taking the 12 and plugging it back into your equation. Now, next one, number 19, says Marvin went to the fair and paid 75 cents per ride. If he spent $13.50, how many rides did he ride? So now we need to use an equation to solve and check our answer and define the variable. So, if I know he spent a total of $13.50, I need to know how many rides he went on, right? I know that each ride actually costs 75 cents. Do I know how many rides he went on? No, that's my unknown. So the way we represent an unknown is with the variable. So repeated addition, I said, guys, is also called multiplication. So 75 cents plus 75 cents plus 75 cents, and so on. We can also multiply, especially if we don't know how many rides he went on. So I'm going to go ahead and solve for X. This is a multiplication problem, so I'm going to divide on both sides by 0.75. This cancels. I'm left with X. Bring down my equal sign. Now 13.5 divided by 0.75 gives me 18. 18 represents the amount of rides he went on. So X is equal to 18 rides. Okay, so let's move on to number 20. So number 20 says 28 is greater than or equal to B. Now, I want to, I told you with inequalities, I like for the variable to be on the left side. So I'm going to put it on this side and 28 on that side. However, this sign, it's like the alligator mouth that we talked about, is trying to eat the 28. So if I switch that order, I need to make sure that that is still eating 28. So my inequality would flip too. Do you see how it's still trying to eat the 28? Yes. So now it says B is less than or equal to 28. This is the same thing. This is the opposite of saying 28 is greater than or equal to B. So now I'm going to go ahead and graph this. I'm going to rewrite this real quick, and I'm going to create a graph. So guys, my only standard for a graph for you is add the number in question, one number before and one number after, okay? So here's 28, 29, and 27. So this is actually going to be, what you need to ask yourself is open or closed circle, and then what direction. So this is actually going to be a closed circle because we have the or equal sign. This closed circle means that 28 is also a possible solution, that when I put 28 for B, that would make this inequality true. 28 would be less than or equal to 28, okay? Now I gotta figure out the direction. The way I would do that is create an arrow, and that arrow is pointing left. Okay, so this arrow means all these numbers going that way are possible solutions. Now, guys, this little trick up here only works if that variable is on the left side. If this B was still on that side, this trick would not work, okay? So I'm gonna go ahead and list possible solutions. So 28, 27, and so on. Because if I plug in 28, that makes this inequality 2. If I put 27 in here, that makes it true because it's less than, okay? Now remember, you can't graph an inequality until you have simplified, okay? So let's look at number 21. Number 21 says n is less than 12. My variable's on the left-hand side, so I can go ahead and graph this, and there's nothing to simplify. Now, I'm going to go ahead and add 12, 13, and 11. Okay? This is actually going to be an open circle at 12, meaning this, if I plug in 12, it would not make that inequality true. That is a false statement. 12 is not less than 12. Okay, so now I have to figure out the direction. So that's left. Okay, so all these numbers, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, would actually make that inequality true. Okay, so 11 is less than 12. Okay, number 22 says x is less than or equal to 24. So I'm going to go ahead and create my graph. Again, I told you all you have to do is that number in question, one above or one greater, and one less than that number. So this is actually going to be a closed circle. Closed circle at 24. Meaning that if I plug in 24, that would make this inequality true. 24 would be equal to 24. Now, since my variable is on the left side, I can use my little trick. So that means my arrow would be that way. So all these numbers, 24, 23, 22, 21, and so on, would make that inequality correct. Okay? All right, 23 reads y is greater than 4. So this is simplified. I can go ahead and graph it. So 4, 3, and 5. So this is going to be an open circle, meaning I can't. 4 would not be a possible solution, and it would be to the right. But 5, 6, 7, 8, and so on would be possible solutions for that inequality. Okay. And now we're going to move on to number, number 24. So number 24 says, write an equation to describe the relationship between the amount of money and the number of cookies that can be purchased. So guys, this actually goes back to direct variation. And I told you direct variation will always come in the form of y equals k times x. So x won't change, but this k will. So let's go ahead and write our kind of skeleton equation. So this says, if you look at the graph on your study guide, the number of dollars, for every dollar sold, I can purchase 5 cookies. So $1 would get me 5 cookies, $2 would get me 10 cookies. So I notice that I increase by 5 every time on my y value. So my y-axis is the number of cookies. So that increase is going to be my coefficient. So I'll show you guys that if I have a table, if I had $1, if I plug in $1, I can go ahead and erase that. Y would equal 5 times 1. If I plug in 1 for x, which is here, I get y is equal to 5 times 1 is 5. So this 5 would go right here. And you can see it's already forming to that table we have on our study guide. So I'll show you, just to confirm, if this is our function we created, y is equal to 5x. If x is 2, y would be 5 times 2, so y would equal 10 cookies. Alright, so now I'm going to take these points and I'm going to graph them. So before I graph that, I have to figure out what's my independent variable, that goes on the x-axis, and what's my dependent variable, that goes on the y. So my independent variable would actually be the amount of money I have. The more money I have, the more cookies I can purchase, right? So I'm going to put money or dollars on the x-axis. So actually I'll say money, and I'll put dollars in the parentheses. Okay, so I'm just going to do 1, 2, 3, 4. So this is $1, that's $2, $3, and oops, sorry, let me scoot that down real quick. So money and dollars. And on my y-axis would actually be the amount of cookies, and we can see that because our x-axis is always going to be the independent variable. Our y will always be the dependent, and it even told you that the number of cookies was our y, okay? So I'm going to do this by 5, 10, 15, 20, okay? Fix that 5. So this is number of cookies you can purchase. Alright, so now we're going to graph it. If I have $1, I can purchase 5 cookies. So I'm going to put a point there. If I have $2, I can purchase 10. Wow, guys, sorry. 3, if we go back to our study guide, we can see it on that chart. It says if you have $3, you can purchase 15 cookies. Do you guys notice how this is proportionate so far? $4 means 20. Now, I told you that if it's a direct variation, it will go through the origin, which is 0, 0, and it will also form a straight line. So it does, and that works, okay? So we have finished the study guide. If you guys have questions, you can watch this again, rewind as needed. If not, you guys can send me a remind as well. Good luck, and I'll see you tomorrow.